Autism is the fastest rising developmental disorder in the world. It affects children throughout industrialized countries. But immigrants from many non-industrialized countries are being hit even harder.
This is Ali, he's 13 years old, he's autistic. This is Afshir, he's 12 years old, he's autistic.
In Somali communities in Sweden and the United States, rates of autism are up to 4 times higher than non-Somalis. Here in Toronto's Somali community, autism rates are also inexplicably high.
This is my brother. He's autistic.
Why Somalis and other immigrants are so badly affected by autism is a mystery. But it's not only them. Autism is rising sharply everywhere. And so far, medicine can't tell us why.
What we were told was, we have no explanation. Things like this just happen.
Autism's rapid rise, especially among new immigrants, is a clue pointing to environmental causes. Now, some scientists are zeroing in on bacteria in the gut as a key to what's traditionally considered a disorder only of the brain.
The traditional way of looking at autism as a specific brain insult that is largely permanent and unreversible may be somewhat outdated.
Right now, all that most doctors will recommend for this puzzling disorder are behavioral therapies like this.
There enough. It's a toy. We're playing with the toy. This is how we play with the toy.
Autism is a spectrum disorder, so you can be a little bit or a lot autistic. There's no typical case and no prescription for handling it. 50 years ago, autism was considered rare, affecting only 1 in 10,000 children. Now, rates around the world range from 1 in 147 in parts of Europe to a shocking 1 in 38 in South Korea. The rate in North America is 1 in 90 children.
If you continue this up, then eventually, about 25 to 30 years' time, you get autism as the norm in an American family rather than a rarity.
The outlook might be even more bleak for children of immigrants. Studies in Europe have found higher rates of the disorder amongst children of immigrants from Africa, the Caribbean, and Asia. So much so that Somalis have begun to call autism the Western disease. Researchers are wondering what it is about their new environment that seems to trigger this disorder.
Hi, baby. How are you? Say hi. Say hi. Okay, let's go home.
Adar Hassan lives in Toronto. She has 4 children. 2 of them, Abshir and Ali, are autistic. They both started out as normal babies.
The first year of his life, I would say, was as normal as you can be, even more normal than my 2 previous children.
Touch our floor.
But suddenly something happened.
Press 2 more floors.
It all started after Ali was treated for recurring ear and chest infections with multiple courses of antibiotics.
He started, refusing coming near me. He started crying all the time and going under the table, things like that. He began walking his toes and refusing to eat food, just want to drink, cow milk. He was having a diarrhea, 10, 15 times a day. And his eyes, it's not even there, he's like another world. And no one helping, going this doctor after another doctor and after another doctor. How many doctors I've been when I was struggling with Ali's condition? No one helps.
You want to go outside or you want to play?
70% of children with autism also have gastrointestinal symptoms, and the severity of their gut problems is highly associated with the severity of their autistic behavior.
You want to feed Cookie Master?
Like many parents, Adar noticed her boys only wanted to eat carbohydrates and dairy, and she found that limiting those foods made a big difference.
We adopted the Western diet, but When my kids got diagnosed and did a lot of research, I find out, all the ways always better, old-fashioned way, cooking, from scratch, doing as fresh as you can,
Abshir and Ali have fewer health problems now, and they focus better and are less hyperactive. But Ali is completely nonverbal, and both boys still need constant care.
Juice, yum. Hey, easy.
All the new immigrants is facing the same thing, and even the Canadian, they're having the same issue and same problem. But something really needs to be explored because these kids they're really sick.
Adar's search for answers brought her and her friend Idman here, where desperate parents are looking for anything that might help. The annual Autism One conference in Chicago is the largest and most comprehensive of its kind. Here, scientists and parents alike come to get the latest trends in scientific research and sometimes unconventional treatments.
We're New Beginnings Nutritionals. We're a supplement company, and we're highly
with New Life Foods. We offer gluten-free, casein-free, and soy-free. The essential fatty acids improves brain function for children with autism.
Hi, this is Isaac. He's a robot.
Hi, I'm Amy
we are
from
here
Living Well, designed by Amy.
Hi, we're standing in front of some hyperbaric oxygen chambers.
If you're not satisfied with it, I will personally, as owner of the company, refund your money.
There is a revolutionary new product that has come out on the market that is a
GPS real-time tracking device for children with autism. Check us out at www.
With no official medical protocol for treatment, parents are frustrated with the lack of options.
As parents, we want to use science-based treatments and therapies, but there's a certain sense that we can't wait for science to catch up.
The term autism was first coined in the 40s and was thought to be the byproduct of cold, detached mothering. And so the term refrigerator mother was born, and with it a heartbreaking trend in blaming the mother that would last for decades. From there, the culprits have been everything from nerdy parents to pollution, to television watching and food allergies. As statistics on the disorder have grown, so have theories.
Mr. Wakefield, thank you very much indeed for...
The most contentious of these has been the suggestion that childhood vaccines are causing autism. Andrew Wakefield's 1998 study, published in a prestigious medical journal, launched a 13-year avalanche of controversy throughout the world. Even after Wakefield's methods were discredited, vaccination rates suffered a steep decline.
No regrets, Dr. Wakefield. No regrets, thank you.
Study after study has found no connection to autism, but vaccine theories, and Dr. Wakefield himself, still have followers.
Okay, I'm a big fan.
Lately, the majority of the research funding has been invested in work on the link between genes and autism. Dr. Stephen Scherer heads the Autism Genome Project at Toronto's Sick Kids Hospital, part of an international consortium of researchers. They're projecting that over 100 genes may contribute to autism, and so far they've identified 6.
The goal of our research is to find which genes are leading to the development of autism, and so when we make a discovery and we find a gene involved, it starts to explain part of this medical mystery. But it doesn't tell us specifically why that gene has been changed or mutated. We also know through other studies that environmental agents can lead to increased rates of genetic changes. So certainly that's a possibility. We can do those experiments once we know what the target genes are, because we can test in the laboratory which environmental agents have effect on how those genes are replicated or turned on or turned off.
Back at the Autism One conference, Dr. Derek McFabe is just beginning to attract attention with a new idea that ties environmental factors together. He thinks the gastrointestinal problems of many autistic children are a major clue. His unorthodox message is gaining ground in the scientific community and speaks to the experience of parents.
Thank you very much. You have a huge bacterial population in your gut, and when you eat, you feed them. And what they produce has profound effects on behavior. When you really look at the research, Infection and gastrointestinal infection and antibiotic use seems to be one of the underappreciated but rapidly emerging causes possibly for triggering or worsening this disorder.
Get propionic acid out of the brain.
This is our hypothesis. So by not eating carbohydrates, it may be a reduction in feeding these bugs to make it.
Also at Autism One is Dr. Martha Herbert. She's a Harvard professor and pediatric neurologist who specializes in autism and how conditions in the body affect the brain. She also sees autism's connection to gut bacteria.
The gut microbial area is exploding before our very eyes right now. It's becoming clear in more and more publications that gut bugs affect the brain, that gut bugs affect psychiatric conditions, and that there's a mind, brain, body continuum through the gut microbiome. And so I think it's more plausible than we ever could have imagined that gut bugs may profoundly affect brain function and behavior, including for autism.
So this may be one of the reasons that particular diets that seem to be...
The gut bacteria theory reinforces what Adar has seen in her son's responses to different diets and in her community's high incidence of autism.
It doesn't surprise me to hear that if you shift a population from Africa to America or Canada, that you get a shift in disease profile, and that would include autism, potentially.
Dr. Jeremy Nicholson and his colleagues at London's Imperial College have been looking at intestinal flora and their role in health for years. Metabolites, which are the products of the processes of the human body, reveal a great deal about how an individual's body is working. One of the easiest ways to study metabolites is by looking at urine.
So there are thousands of different metabolites in urine, and all have got their own unique radio signatures. So what we do is we drop a sample like this, it's got about 0.5 ml of urine, into a very strong magnet. It realigns all the magnetic nuclei, and we can pump in radio waves and then listen to each molecule basically sing its own frequencies.
Dr. Nicholson became interested in the mystery of autism a few years ago and launched a large-scale study of urine from autistic children, their non-autistic siblings, and healthy, unrelated children.
Matt, hi. Hello. How is it going?
So we say we have some more tweaking to do, just of the hardware, really.
So I've had a good idea for a change.
Absolutely, yeah, yeah.
The question was there anything about autism that made it different to normal? And so we profiled a number of children. We found they're actually quite different in many different respects. One of the most interesting being that they have significant differences in gut microbial metabolite profiles, implying that the gut microbes inside them were working somehow in a different way to normal children.
Dr. Nicholson has found that diseases have changed in the Western world in the last 60 years, and that increased rates of certain disorders, like autism, correspond to a country's level of industrial development.
Since the Second World War, we really entered the modern age of technology, and with that has brought us the blessing of McDonald's and all the other things like that, and all the highly processed foods. It's also brought us antibiotics.
About 2/3 to 3/4 of American antibiotic production is used in livestock. They are not designed to eat grain, they're designed to eat grass. And the grain, basically, to put it crudely, gives them acid indigestion, which you kill off with the antibiotics. And then the antibiotic affects them, gets into the water supply. We started using a lot of pesticides and chemical fertilizers. We've used a lot more corn, which has omega-6 fatty acids, but not omega-3. We use a lot more refined foods and processed foods, which don't have as many nutrients as they did in their fresh forms. So I think that there's a relationship between food policy and vulnerability to autism.
So we've changed more phenotypically, more in terms of our biological signatures, our biological makeup, and our lifestyle in the last 50 or years or so than we have probably over all our time since the Ice Age. Right, that's a giant change in our biology, so it's bound to have a whole series of consequences. And one of the consequences, we think, is that the microbes, the fundamental activity of the microbes and the composition of the gut microbes has changed.
Norwegian microbiologist Tor Midtvedt has pioneered research into how gut microbes influence health and early development. In fact, Scandinavian researchers have been leaders in finding critical links between the gut and the brain. And now, finally, their ideas are starting to catch on.
And now the focus is in the GI tract, and I'm very pleased with that. It should have been done decades ago.
In his work at the Karolinska Institute in Stockholm, he's been studying gut microbes for the past 40 years. He's found that, put together, they make up the most biochemically active organ in the body.
If you take the size of the cell, your cells are at least 100 times greater than any microbes that are within you. But if you take the number, then it is the other way around. The microbes, and most part is in your gastrointestinal tract, are outnumbering you with at least 1 to 100.
As soon as we are born, trillions of bacteria in our guts begin to form. This is called the human microbiome, and it's one of the densest microbial communities on Earth.
And when they are established, then you have a long-term effect of establishment. For each of them can switch on and off genes in your cells, and each of them may produce or may not produce some of the compounds that will act upon you.
One of the keys to normal development is acquiring the right microbes during critical windows of childhood growth.
So if, for instance, a child were to acquire an abnormal set of microbes, or let's say a hostile set, it is possible that the metabolic development of the child is impaired, and that could include brain development. The important thing to remember in this context is that the development of your microbes from the time you're born, it takes about 3 years to get a sort of adult set of microbes. That's exactly the time course over which synaptic development occurs in the brain. You're making all your brain connections. They're pretty much completed by the age of 3.
A disturbance in this early microbe establishment might explain some kinds of regressive autism. This devastating phenomenon is when a child develops normally for up to 3 years and then inexplicably retreats into their own world. Just outside Chicago, this sudden regression became a clue that led one mother to push for answers and a new discovery.
This is Andy at 1 year old. Oops. He had perfectly normal development, hitting all of his milestones. Mama, Dada, Baba, bye-bye, by, the age of 1.
Andrew is the youngest of Ellen Bolte's 4 children. He was born in 1992.
This is his 18-month shot. And this is where he's gone.
A medical checkup found fluid in Andy's ears. The physician diagnosed an ear infection and prescribed 10 days of antibiotics. But the fluid persisted, so the doctor prescribed more antibiotics.
He was on his 6th course of antibiotics within a 2.5, 3 month period. I guess the only way I can describe it is he started to shut down. He became withdrawn. He didn't want to be touched. He didn't want to be held.
Eventually, they found that a milk intolerance explained the fluid in Andy's ears. He was taken off antibiotics, but his behavior remained.
He regressed so dramatically that instantly he was seen by many specialists. Ultimately, though, what we were told was, we have no explanation. Things like this just happen. He has autism. He has very severe autism. At this point, Andrew is 4 years and 9 months old. He didn't like to really play with toys. He would pull the books off the bookshelves or VCR tapes off and just play with them on the floor, but not really in a meaningful way. He was very stiff and postured. A lot of toe walking, which is seen in children with autism. Of course, he's not really making eye contact here at all. He had no language at this point, just he uttered noises. Mostly he uttered E, E, over and over again. He seemed healthy, except for, and this is very important, he had a lot of GI symptoms. His stool was foamy, mucousy, bulky. It wasn't like anything I ever seen come out of a kid before, and with 4 kids. You know. He started to refuse to eat solid food, but he would eat non-edibles, tissue, paper, ashes from the fireplace, the drywall off the walls.
Ellen's biggest fear was that the developmental window for Andy to acquire language was quickly passing. She had to do something.
I felt called to start researching in spite of having no medical background at all.
Ellen's starting point was Andy's history, compared with her first 3 children's development. The only difference she found with Andy was his experience with antibiotics. It didn't take long for her to stumble upon the name Feingold.
One of the lesser-known problems with antibiotic use is that they do impact the bowel flora.
At 90 years old, Dr. Sidney Feingold is still considered one of North America's best microbiologists. He's been researching bowel flora since the 1950s.
The human bowel is a remarkable organ. If you were to stretch it all out, it would be the dimensions of a tennis court. It has many different bacteria in it normally, a great variety, probably between 1,000 and 10,000 different types of bacteria. These children are susceptible to ear infections, and so they receive antibiotics, and the antibiotics intend to select out certain organisms while they suppress much of the rest of the flora. Now, the organisms that tend to persist are Clostridia.
Clostridia are a family of around 100 species of bacteria. A few of them are pathogenic, extremely hardy, and resistant to most antibiotics. They also produce neurotoxins that affect the brain. But Ellen found that it might be possible to attack the Clostridia specifically with a particular antibiotic.
I really felt, you know, if we go on this premise, if we act on this premise, he can be helped. An antibiotic that specifically targets Clostridium in the intestinal tract could potentially be a huge benefit to him. So I started writing doctors. Many of them simply referred me to somebody else because they felt it was, you know, outside of their expertise. It didn't clearly fit with infectious disease. It didn't clearly fit with gastroenterology. It didn't clearly fit with neurology, immunology. So I was hitting on all of these different specialists.
After 15 months and 37 doctors, Ellen found a gastroenterologist who agreed her theory should be tested. They began Andrew on an 8-week trial of one of the only antibiotics known to kill Clostridia bacteria.
The results were astounding.
Oh, wait.
Within a matter of just a few weeks, he became calm. He was aware of his environment and responsive enough to begin potty training, which was instantly successful.
Good boy!
He's now beginning to play with toys. He's leaving clothing on.
Yes. Yes. That's your new word, huh? Yes. And no. No. Good boy. Good thing. No. Oh, good boy.
He's putting puzzles together.
Does them all backwards. He did his name backwards. He threw his all backwards.
Oh, nice kisses. More kisses?
That was the end of the 8-week trial. And Dr. Sandler on the spot said, well, we need to test this with more children.
At this point, Ellen and her doctor took their story to Sidney Feingold.
So, Julie, you got some black colonies there?
Yes, these are growing nicely actually on this plate here.
And he agreed to help with a pilot study of 11 more children.
How long did they take to show up?
That took 2 weeks to come up.
2 weeks.
Pigmentation, yeah.
I've always felt that bacteria in the gut do things other than cause infections of the classic type. There was never evidence for it, and here was an opportunity where, even based on that one initial patient, Ellen Boldy's son, it seemed very logical that bacteria in the gut played an important role.
Sure enough, Dr. Feingold found Clostridia in higher amounts in the stools of the test children, and that 80% of them improved on the antibiotic vancomycin. But there was a catch. In a hostile environment, Clostridia produced spores, essentially going into hibernation.
Actually, spores are resistant to all known antibiotics. There isn't an antibiotic that I'm aware of that can kill a spore. Now, I was very concerned that even though we had treated the bacterial cells, I knew that spores remained. And I was quite concerned that when we removed the vancomycin, that any spores remaining in the intestinal tract would germinate and would be right back in business, shall we say. And that, sadly, is exactly what happened. So, you know, there was a lot of very important skills that Andrew was able to maintain, but the behavior, the screaming, the irritability, the don't touch me, I don't want to look at you, the walking on his toes again, repetitive behaviors, those pretty much all came back.
Ellen co-authored a paper with several doctors on the results of the study, and in 2000 it was published in the Journal of Child Neurology. The paper didn't cause the stir in the medical community that was expected by its authors. Though several researchers have since replicated the finding that autistic children have higher levels of Clostridia in their gut, doctors have been slow to pick up the gut bacterial link.
I think we're going to have to do quite a bit more to convince people that are not infectious disease trained or trained in microbiology that bacteria can really do these kinds of things and that they can be controlled.
The medical community may also have ignored Ellen and Dr. Feingold's paper because it was thought to be promoting wider use of vancomycin, which is a drug of last resort in the fight against antibiotic-resistant bacteria. But there were other issues at play as well.
When the results of that study were released, it seems like what everybody focused on was the fact that the children regressed. And I acknowledge the children regressed, but that is not the point. Why did that happen? Why did they get better? Could it be a neurotoxin-producing bacteria in the gut that was suppressed by antibiotic treatment? I think that that's a valid question, and I think it's a question that has not been answered in 11 years since we published that paper.
At his lab at the University of Western Ontario, Dr. McFabe is picking up on Ellen and Dr. Feingold's work with his own gut bug theory.
I was aware of the paper by Dr. Sidney Feingold in UCLA showing unique populations of Clostridial bacteria in the digestive tracts of these children with regressive autism.
Dr. McFabe realized that one of the byproducts of Clostridia is a short-chain fatty acid called propionic acid. It's not a neurotoxin, but it does have dramatic effects.
And then in my previous work, we were working with this compound, propionic acid, And we found that for such a simple molecule, it had very widespread effects in the central nervous system, affecting brain development, metabolism, and immune function. And then, we sort of put 2 and 2 together, and we said, hey, these bacteria in the gut, when children eat carbs, ferment the carbs and make propionic acid. And in addition, some of the foods that these children craved, in addition to being high carb, did in fact contain propionic acid as a food preservative.
Propionic acid is labeled on food packaging as E280. It's a commonly used preservative in many bread, cake, and cheese products made and sold throughout Europe, Australia, South Korea, and North America.
So we thought to take propionic acid and give it in small amounts to rodents and see if the behaviors or brain changes looked anything like autism, and whether or not these behavioral and brain changes were transient.
Dr. McFabe's control subjects exhibit typical behavior. Rats are highly social animals. They greet by sniffing nose to tail and interact as they explore their surroundings. But when a propionic acid solution is introduced, this all changes.
What we noticed remarkably within 2 minutes of putting this propionic acid in, this animal immediately starts exhibiting some very peculiar behaviors. Obviously, he's hyperactive and moving very quickly, and then repetitive behaviors. Here you see an abnormal posture of walking with a hunchback. And it's an unappreciated part of autism in that patients often have toe walking, abnormal posturing, arched back. So now we'll place another animal that's been given propionic acid. And a peculiar thing happens. They show none of the normal social greetings of two rodents seeing each other.
A video tracking system records and compares the obsessive and antisocial PPA-treated rats with the normal rats. Other experiments showed responses such as rigidity and object fixation, and the intriguing fact that the effects of PPA wear off.
So now we're about a half an hour after we've exposed these two animals to propionic acids, and their behavior afterwards reverts back to normal, and it's a fat, so it's burned through metabolism. The animals become more social. Usually after their escapades, they tend to just go back to sleep. So again, we have a reversibility of hyperactivity and a reversibility of social behavior.
The autistic-like behavior of PPA-treated rats was compelling. But Dr. McFabe and his team wanted to know exactly what PPA was doing to the brain.
So do you have the lipids on the PPA rats?
Yes, here it is. This is what the final product looked like. When I finish this analysis, we'll be able to quantify whether or not there's any alteration in any of these components.
Brain fat composition is intertwined with behavior. So Dr. McFabe is working with lipids expert Dr. Ray Thomas, who's been examining PPA's effect on lipids, the fats that fuel brain cells.
What we've found is that when we give propionic acid, which is a metabolite from enteric bacteria, it has the propensity or the potential to alter brain fats. They alter the omega-3s, the omega-6, the saturate level. And these alterations that we've found in the brain is closely related or similar to what has been reported in the blood of autistic patients. What we've shown is that with propionic acid, you get a fast change.
Remember, families are saying, my child gets worse with something associated with gut or diet. And sometimes when I make manipulations with diet or gut, my child gets better. We wanted a model that gets worse and better. And what Ray found were these amazingly specific changes in very key lipids that have to do with brain development, brain functioning, and brain energy metabolism. Imagine these gut bacteria produce the propionic acid as a metabolite. It'll fly through all bloodstreams to multiple cells, like all the other fats. But then when it comes to the nervous system, it can get in because it's a small molecule. But there are actually very specific compounds called transporters that actually grab the propionic acid and kind of suck it into the nervous system.
Once in the brain, PPA changes brain fat composition to be similar to that of autistic patients. The brain is 60% fat, and cell function and our behavior are directly related to how those fats are composed. And there's more. PPA could even be switching the genes associated with autism on and off.
Imagine this little molecule from your gut going directly into the nucleus where all your DNA is and acting as a switch to turn on and off important genes having to do with brain development, learning, and memory and metabolism. It's very intriguing that such a simple molecule can do such specific things in a brain metabolism and function that are very consistent with what's found in autism.
So far, there are no studies showing that PPA or E280 isn't safe for adults when used as a preservative. But Dr. McFabe's work with animals shows that gut bug metabolites like PPA could be triggering autism in susceptible children.
Normal or near normal people exposed to high levels of alcohol are not behaving as their normal selves. And by analogy, I think normal or near normal children exposed to high levels of propionic acid, gut bug metabolites, are not themselves. By removing the propionic acid, by either getting rid of the bug that makes it, not feeding the bugs that are there, healing the gut, or using compounds that help break it down, that will be the approach of treating this disease.
Yeah?
Oh, pop, pop.
Oh no!
It's painful, to be honest. It's painful to watch it because we were so close. I really think that we were so close a decade ago to fixing this, but no one would listen.
Many parents have taken up the gut bacteria theory and are using it to devise treatments.
Andrew is now 19 years old. It's hard to believe that it's been that many years. I do think that it's a war in Andrew's intestinal tract. There is a colony of, I believe, neurotoxin-producing bacteria that established itself and set up camp and set it up good and strong and at an early age. And basically what you become colonized with as a child, those are the bacteria you die with.
Keeping Andy on powerful antibiotics indefinitely wasn't an option. Long-term use would have dangerous side effects. So Ellen turned to other therapies. She has found that by giving Andy massive amounts of probiotics, supplements containing benign bacteria, his symptoms are controlled. So even if Andy's Clostridia can't be eradicated, they can be beaten back with waves of competing bacteria. Studies have confirmed that probiotics have helped other children as well.
He functions very well, and that's a relative term. When I compare to our baseline, I'm very happy with what he can do. Andrew is very self-sufficient. He can cook his own breakfast, pack his own lunch. Academically, he struggles beyond, a third or fourth grade level. He still has some very impaired social skills. He is, though, delightful and a joy to be around the house. Andrew, pretty soon you have to go to your track meet.
Hey.
And what are you going to do at your track meet?
Run fast.
Run fast.
Besides hopeful signs that altering gut bacteria may control autism, new research in Canada is looking at the possibility of medically replacing a whole internal ecosystem with a healthier one.
This to me is like a golden opportunity to really look and see what might be going on in this situation, where I can sort of see that there's some problems with the gut and problems with development.
Dr. McFabe and his colleague, Dr. Emma Allen Vercoe from the University of Guelph, have begun a unique collaboration with the Somali community in Ontario. Joining forces with parents, they've started a study that will analyze fecal samples from Somali Canadian autistic kids. Dr. Allen Vercoe hopes it will reveal what's amiss with their bacterial profile.
And also this entire change that the Somali population has when they come from Somalia to Canada, to a completely different country, a different culture, different foods in particular, and hearing the changes that might be happening in the diet that might therefore have some kind of knock-on effects with the bacteria that live in the gut. The old adage, we are what we eat, I think that's very important. In Somalia, they eat a lot of fermented foods, and that's a very staple part of their diets. They wouldn't necessarily do that in Canada.
It's the way we lived, you know, the food we used to eat. No corn, no soy, no genetically modified things, no nothing. Everything is as natural as they can be. No pesticides, no hormones, nothing.
And maybe they have a microbe that's missing now from their diet because they're not getting it from fermented food. And maybe that microbe might have some direct interaction with other microbes in their gut. Now, if that's a missing piece, it's no longer there. Their gut microbiota might actually not be functioning correctly anymore.
Dr. Alan Vercoe is working on the idea that the ecology of gut bacteria could be medically manipulated.
Over here we have the robogut, which is a very sort of coined phrase for our artificial gut system that we have here. Now here we're able to actually recapitulate the environment of the human gut, which enables us to culture some of the organisms just by growing them with their friends, essentially, as part of an ecosystem.
Dr. Alan Vercoe approaches her work as an ecologist, using the roboguts to create whole microbial communities, then manipulating them to see what happens to the stability of the ecosystem.
It's an ecosystem that is incredibly diverse, in fact, probably one of the most diverse ecosystems on the face of this planet. And I liken it to a rainforest. Everyone knows what happens when you start stripping species out of an ecosystem like a rainforest. You end up with a barren sort of landscape, and really the ecosystem just kind of crashes. And this is what we think is the kind of the basis for many diseases now.
The concept of treating gut microbes as an ecosystem leads to hope that someday a whole flawed set of microbes could be replaced.
The idea would be that we would get rid of the bad ecosystem with antibiotics, with purging of some kind, and then replace it immediately with a healthy ecosystem that would allow that to establish and to take on the job of a healthy ecosystem.
So autism can be a shortage of some microbes and not a presence of some microbes. And that's difficult to investigate, but we have to do it.
In Bergen, Norway, practical work in devising therapies for gut-related autism is becoming a science. And it can be seen in Tor Midtvedt's own family. Dr. Midtvedt's nephew, Lars Ørsland, and his wife Britt have 2 sons. The younger one, Eric, is autistic.
How old was he when you first made the diagnosis?
He was 6 years old when he got the diagnosis.
Okay.
But since he was 2.5 or something like that, he started to slip away. We didn't feel that we really had contact with him. But that was after he had some stomach illness when he was about 2.5.
Today there is another visitor besides Dr. Midtvedt, Hanna Björg, a biochemist. Björg gave up a successful career in banking to study how to treat autism biomedically.
Well, the history of why I'm working with autism at all is that I have 3 children that also have needed a lot of help. And we went through 17 doctors here to try and get help for the children. And none of them could help the children.
So, Hanna, what do you think about this test?
Björg traveled to America to find answers and was able to improve her children with what she learned. She decided to bring that knowledge home to Norway. Björg co-founded a clinic in Oslo, one of the first in Europe. Its mandate is to treat autism by treating the body. It's an idea that is still relatively new.
The official statement is that in Norway is that autism is not treatable. That's the official statement in Norway. It's something new for the medical community, but probably not for the parents who's been working with kids for a long time.
With every new case at her clinic, Björg starts with a comprehensive examination of the child's history and routines.
We always have a 7-day period where the parents tell what the children eat, how they behave, reports from the school, and how they sleep, and with that as a base, we go further and do some medical examination of the child. One thing that we see is that on the vitamin side, it looks like some of his values has gone up quite a bit. And it's interesting to see if that has any relation to his bacterial status or not.
In consultation with experts like Dr. Midvet, Björg runs tests investigating gut function. Then she makes careful alterations in diet while monitoring the child's bacterial flora and behavioral response.
We normally start with milk and wean them off that and take away all the different products that have milk in it, which are a lot. And then you do the same with gluten.
We met Hanne and her colleagues in Oslo, and we realized that what we thought was without gluten, without milk, without corn, really wasn't.
So I have to make all the bakery myself, and I also we had also to divide the kitchen in as one gluten-free place and one with gluten.
Gluten and casein-free diets are a common approach to healing a disturbed gut, but there's no scientific agreement on why it helps some kids. The best explanation is that a microbial imbalance impairs the body's handling of these foods, and the brain is affected. Hannah's work with Eric has helped him improve socially and academically. But his parents would like even more improvement.
It's very important that the parents fight for their children and that they are a team together with the doctor and the advisors, because it's the parents who are closest to the child. So the parents can then tell the doctor how the child is developing.
There was a carefully conducted clinical trial of a gluten-free, casein-free diet, and after the better part of a year, they had to close down the placebo arm because the kids on the diet were doing so well. To most people, the idea that someone could get over autism is completely inconceivable, because they believe that autism is a lifelong immutable condition wired into the brain that cannot be changed. And I've come to the conclusion that there really isn't evidence to prove that assumption.
What's this?
5 minutes.
Yeah.
Cool down.
That's your cool down.
Opposite of exhausted is?
Opposite of exhausted is have energy.
Have energy means?
Can keep going. What's this up here?
Distance.
Yeah, that's how many miles you're running, huh?
Okay.
Yeah, I don't think you ran 345 miles, honey. Okay. But it looks good.
I cling to the hope that research is going to be done in time, and that he'll be able to receive treatment, and that he will be able to still respond due to plasticity of the brain. Who's to say?
There could be a future where we screen for these weird fatty acids in children, we screen for these bacteria in children, and we help children by either eradicating the bacteria, having healthy bacteria to keep the bad bugs down, helping the person to metabolize these fatty acids, just like giving insulin to a diabetic to help them metabolize sugars. The model reflects a changing neurological disorder.
They really have a GI issue. And when you have a gut problem, nothing else is going to work. I would love to hear his voice. That's the most important things. He understands more now. He understands everything you tell him, but he can't say the words. So that's one of the biggest for me, to see, you know, Alice speak and call me mom one day.
As the evidence grows that disturbances in gut microbes at critical stages of development are linked with some kinds of autism, and with scientists studying the exact mechanisms of how these microbes affect the brain, there are signs that the condition is treatable and even preventable.
Until fairly recently, we assumed that, or we just didn't really give the gut microbiota any thought whatsoever. And we just thought of it, we knew that the bugs were there, but we thought that they were just benignly there because they ate the waste products that we couldn't eat, and so why not? The finding that they're actually there and their importance and they're doing something that is contributing to health is a fairly new realization. We're really at the dawn of realizing that.